All right, what's up, guys? Welcome to day 5, day cinque, day cinco. This is the warm up. So, again, with the warm up, make sure you're trying this out on your own before you watch this video. So, if you haven't done this yet, do this first, do your best, and you could always check through to make sure you got the right answers. Okay? If you have any questions and you're in my class, you could always email me here. If you're in Miss Cook's class, make sure to email her. Again, we're both always ready to help. Just remember that we are free from 9 a.m. to noon. So during those hours, that is when I'm available. If it's after or before that, that makes it a little worse for me because, again, I'm doing other stuff too. I'm doing my master's program, and they want us to give you guys some hours to work. So please just make sure you're reaching out to us during that time. That'd be awesome. Okay? This is now officially my 4th take of doing this video because I am at home with my family, so mom, dad, sisters, and they keep interrupting. People have no sympathy. They have no respect. Maron. Okay, well, anyway, enjoy. Here we go, starting on day 5 warm-up. So, see what we got. Angle BPC is 80 degrees. Okay, angle APF is 75. There we go. Angle DPE is 60. And then here's an interesting one. Angle EPF, so this angle, is 2 times whatever DPC is. So what you could do to show that is if this is twice as big as whatever this is, we could call this X, and we could call this 2X. Okay? That's probably the best way to approach it because, again, it's all from this statement saying that EPF is 2 times as big as whatever DPC is. Okay? So let's see what we can do. So one trick that you guys need to get down is looking and seeing where the diameter is in your circle. In this case, CPF or CF here is cutting my circle completely in half in a straight line. So that is a diameter. So something you guys got to realize is that when there is a diameter, it cuts the circle into half. And half a circle is 180 degrees. Okay? So if I know that this is 80 and this is 75, this needs to be 25 because that would all add up to 180. Okay, so angle BPA is 25 degrees. And again, make sure half a circle from the diameter adds up to 180. Sup. Okay. And now we're going to have to find what angle DPC is and angle EPF is. So if you think about your picture, I now have every angle in the whole entire picture. Every angle in a circle adds up to 360. So my equation would be x plus 60 plus 2x plus 75 plus 25 plus 80 equals 360. So add all these up to equal the total of what a circle is. Okay? If we combine like terms, we have 3x plus 240 equals 360. Okay, and then we solve. So 3x equals 120 and x equals 40. Okay, so that means angle DPC is 40, and then 40 degrees, sorry, and then angle EPF is twice as big as that. So this would be 80 degrees. Okay? Hope you guys enjoy. Nice and cute. Okay, next one. Okay, very cool. We have 2 angles here. Okay? The central angle of this picture is 124 degrees. So that means that this arc that central angle makes is also 124 degrees. Okay? That's just based off of what we know about central angles. And if I want to find what X is, okay, this is an inscribed angle. Okay, and with that inscribed angle, we know that it bounces off the side of a circle. So if you see this angle, if you opened up that angle, that also opens up to the same arc that the central angle makes. Okay, so that's why I did this arc first. And if you know that this is always half of whatever the arc it makes is, this angle is 62 degrees. Beautiful. Okay, love it. Another thing we did, and number 3, was we are talking about area of sector. So the area of sector, APB, that's me finding what is the total area of that little slice of pizza. So PB is 15. Where's J? I wonder that. Get it? No? Okay, cool. Arc AB is 120 degrees. That's from here to here. Okay, so if that arc is 120, that means this angle is also 120 because it's a central angle. Okay, so if we're finding area of a sector, okay, that is a fraction of the total area. Okay, so the fraction of what we have here is the angle we have out of 360, and the area of a circle is always pi r squared, because again, we want a fraction of the total area. That'll give me how much area that piece is. So this is 1/3. The radius here is 15, so that's pi of 15 squared. Okay, so that's 1/3 of 225 pi. Okay, and 1/3 times 225, if you want to write the step, 225 over 3 pi. But this simplifies to 75 pi. So again, just showing you the intermediate step of how to get there. If you want to just jump from here to here, that's Gucci with me, homie. You do you, boo-boo. Okay, love it, love it, love it. Okay, let's go to the back. To the back. All right. So same idea here. I'm actually going to let you guys do this one on your own. This is the same idea. Area of sector. You got it, girl. Oh my God, what am I writing? Oh my gosh. You got it, squirrel. Fun thing to do, by the way. If you just take any song and you take the word girl and you just replace it with squirrel, it fits perfectly in and it makes for some good lyrics. So just a little something that you could do. Okay. Okay, here's a fun one. Here's a fun one. Okay. This time, they're giving me the length of the arc. Okay. So that means this is the arc length. All right. They're giving you the answer here. All right. So we know also that SPT, this angle, is 30. And that's all we know. And they want you to find the radius. So we have to kind of go backwards here. But you guys should remember that a fraction times the circumference. Ooh, you don't know how to spell? A fraction of the circumference is the arc length. Okay? That's literally saying like, hey, how much pizza crust am I eating? That's what arc length is. So the arc length is 5 pi over 3. All right? So what we have to do now is kind of fill in what we do know and then what we're looking for. We obviously don't know the radius, so that's what we're going to end up be finding. So let's set this up. So our fraction of this slice is 30 out of the total 360, right? The circumference is still 2 pi r, like it always is, okay? And the arc length of this problem is 5 pi over 3. Okay? So, ooh, this will be fun. Okay, this is 1/12. I know in both equations, the pi's are just going to cancel out really nicely. So this is times 2r equals 5 over 3. Okay? Couple ways to do this. You could really go about it however you want. I'm going to combine this side. So that's 2r over 12 equals 5 over 3. But this is really r over 6 equals 5 over 3. Because, again, simplification of 2 over 12 is 1 over 6. And then we can cross multiply. 3r equals 30, and r is 10. All right, so not too bad if you kind of set it up nicely and go about it that way. Okay? Gucci? Gucci. Okay. For the last one, a circle is inscribed in a square. So inscribed basically means it's fit perfectly inside. So circles perfectly fit inside the square. So they want you to find the shaded area. So again, they don't want you to find the circle. They just want these little pieces here. So the idea, again, it's going to be very hard. There's no formula to find this by itself. But if we do what we've done before and take the big picture, the whole entire thing, which is a square, if I take the total square and subtract away what I don't want, which is the circle, then I'll be left over with what I want, which is this. Okay, so that's how you got to think about it. So luckily, we know the two formulas for these two things. The area for a square is side times side, or side squared. Okay, and we're going to subtract away the circle formula, which is pi r squared. Okay, so we got to find first the square, find what that is, and then subtract away whatever the circle is. So think about it. For the square, all the sides are 14, right? This side's 14, this side's 14, this side's 14. So this would be 14 squared. That would give you the area of the square, okay, which is 196. Okay, but then we also have to find out the area of the circle. So we know it's pi r squared, but we just have to find the r of this circle. So think about it. The radius of a circle is this, from center to edge like that. Well, if you know that this whole side's 14, that radius is half of that, which is 7. Okay, so this would be pi times 7 squared, which would be 49 pi. So again, this answer, they're not in like terms because this is normal numbers. This is with pi. Oh, I'm gonna burp. Oh, I'm gonna burp. Ooh, sorry. And this is the area of the shaded piece in the picture. Okay, hope that makes sense. Have any questions, let a homie know. Peace out.